Test hint number 37. The common charge on ions for the d block elements. Well, I kind of answered that a couple minutes ago when I said most of the elements in the d block tend to lose 2 valence electrons. We know there are several that are exceptions that will lose 1 electron because they steal an s electron to put it in the d. That whole thing with configurations where we don't end on d4 or d9, because they're going to steal an s electron, so it'd be 4s1, 3d5, or 4s1, 3d10, instead of 4s2, 3d9. Most of the elements in the d block, their common ion, will lose those 2 s electrons first. The ones that snuck in before they were supposed to fill because of that orbital overlap, they're technically in a higher energy level. There are a lot more options, and if you look at your periodic table, you'll see that there are several oxidation numbers for the elements in the d block. We'll get to that, but we're still in the beginning chapters of our introductory chemistry class, so for now, for this chapter, we can go with just +2. Some of them +1. Test hint number 38. How Mendeleev grouped the elements on his periodic table. We kind of talked about this at the beginning. He's basing those on properties. They generally went from lightest to heaviest, but they're mainly grouped together because of properties. Test hint number 39. How to determine the number of elements in a given period. I would count them. Okay? You can count. You already know this because you're good at configurations. So look at the orbitals that are filling and how many electrons are in there. Test hint number 40. How to identify the group number of an element from its atomic number. Okay. This question is going to sound something like this. Argon, atomic number 18, is the third element in group 18. What's the atomic number of the 6th element in group 18? Not too tough. Take a look at group 18. Argon's the 3rd, 4, 5, 6, right on. Okay, very easy question. Test hint number 41. How to identify the period of an element based on its electron configuration. Find the element on the periodic table. You can then tell what row it's in. You're not going to need too much help with this, but I will say it might be a good idea to go back and go over the second half of chapter 4 again, just to keep it fresh in your mind, all that business that we did with electron configurations. It's not tough, you know it. I've seen good things with what you're doing in class, but maybe just review it a little bit just so you're sure. We're getting there. Test hint number 42. How to identify the number of valence electrons in a sublevel for a specific element. Okay, so we'll tell you which element, and I might say, okay, gallium, element 31. How many electrons are in the p sublevel? Well, it's the first element in the p block, so it's just going to have 1. If I asked you how many elements or how many electrons are in its s sublevel, you'd say 2. If I asked you how many in its 3D sublevel, you'd say 10, because that has been filled. Count over. Test hint number 43. How atomic size is determined experimentally. Okay, now we don't take little tiny rulers and slap them on top of atoms and measure to 2 decimal places because we want to do our sig figs. We have to do this kind of indirectly, and there are some pictures on Moodle for you to show you how they measure it. We basically zap energy at the atoms that are adjacent to each other. We find the nucleus of one, the nucleus of another, measure that distance, cut it in half, and that's our atomic radius. Take a look at the PDF files I've got posted for you in the notes and resources section for this chapter. And finally, test hint number 45. What happens to valence electrons during bonding? Wow! All the cool stuff. Electrons are lost from metals and gained by nonmetals if it's an ionic bond, or they are shared between nonmetals if it's a covalent bond, or there's the electron C in the D block when metallic bonds are formed. Little preview of the next chapter. Thank you for watching this all the way through. You have a lot of information, but it's not too tough. I think you'll do a good job on the test, and happy studying.